determine the inverse Laplace transform of, okay, this stuff right here. So what you normally need to know here is that when you want to find the Laplace inverse, you need to copy what you've been given, the way it looks, just like this. So you follow the steps nicely. Okay, so once you copy, you use the idea of completing the square method right here on the denominator. So what is on top, the numerator, maintain it. The denominator, you use the idea of completing the square method. So it will look like this. So this is how it will look like. Okay. Thereafter, you maintain the numerator. For the denominator, you simplify here, so you have something like this. So this is how it looks. So how did I reach this stage? Let me just show you how it happened. So I'll start with what is here. We have this x squared, s squared minus 2s plus 5. So what you normally do, write the letter which is right here, s, and then you say minus what is here divided by 2. So whatever is here, make sure I divide it by 2. So it will be 2 divided by 2, which is the 1. Put the brackets, and then the power, bring it up here. You say plus 5. Now what is inside here, the constant which is right here, so it's negative 1. You say negative 1 squared, it's 1. Now subtract it from the constant which is right here. So whatever you have inside here, square it. After squaring it, subtract it from the constant that you have right here. So you end up with something like this. And this is what I have right here. Now after that, try by all means to make what is inside here appear where s is here. So it will be like this: 3, okay, inside the brackets you have s minus 1. Okay, you see the way it looks? So c will come out, 3 will come outside. So it will be like this: you have s minus 1. So that s minus 1, add a 1, okay, so that it doesn't change the meaning, because negative 1 plus 1 is just a 0. It's more like you have not put anything, okay? And then you say plus 7 over the denominator, which is s minus 1 squared plus 4, okay? So at this stage, try to maintain this. So it will be 3, open bracket, s minus 1, close, okay? You see the way it's happening? You close. So now this one will be added to the constant which you have here, okay? We want to match what is right here, what is here, to be the same as what will be here, which is this one. So this 3 will be multiplied by 1, which is equal to 3. So it will be 7 plus a 3, because 3 times 1 is 3. So now your answer, add it to the constant so that you don't change the meaning. So the denominator is like this. Okay, maintain it. Thereafter, you can now simplify things. So we have something like this, and the 10 here goes 7 plus 3 is 10. The denominator will look like this, okay, plus a 4. We are almost heading somewhere. So now we can come to the denominator. We do some stuff to the denominator. So we have got the Laplace table, okay? So for the Laplace table, if you don't know how the Laplace table, try to watch more or search about the Laplace table. So we'll change this, it will be a 2 power 2. You see, 2 power 2. Because Laplace table, there is a property which says that, two properties which says that cos AT is equal to t over t squared plus a squared, okay? The other one will be sine AT is equal to a over t squared plus a squared. So we need these two properties. So I'm trying to match these to what we have here, the denominator. You see there is power 2 here, power 2 here. There is a 2 here and a power 2 here. For the constant a, we have a 2 here. So I'm trying to match these two things. After that, since we've matched this, so we are going to use another property which says that e power at is equal to 1 over s or t. Actually here I'm supposed to be putting s minus 1, okay, or minus a, sorry, minus a, this. So these are the properties that you need to know in order for you to be able to answer this. So once you get these properties, now you can say 3s minus 1 as your denominator there, you put it, the denominator there, you put it, the way it looks, you say plus 10 over s minus 1 power 2 plus 2 squared. So you see, this one looks like this one because what is here and here are a little bit similar. The only difference is that we have got power 2 here and we have a constant here. So this and this are a little bit similar. We have a power 2 here. So this, we know that it's cos what? It's cos. We're dealing with cos here. So what is right here is the same as what is here. So we say 3 e power, what is here, so it will be t, because this is here, look at this, it was a and a positive change to a negative, so meaning whatever power will be here will be a positive. Now we have a constant as a 1, here we have a, so a 1 we're not going to show it, we'll leave it like this, and then we'll say cos, because what remains, if we forget about what is inside, what remains is a little bit similar to what is here. So we'll say cos, and then put the constant here, which is 2t, plus here. This is where I need to be very careful, because what is here is what's supposed to be right here. So what we're going to do to this is this. Let me show you here. You say 10s minus 1 squared plus 2 squared, and then just get what is here, okay? What is here, which is a 10, change it. Don't put a 10 on top here. Put what is here. I'm going to put a 2 so that it doesn't change a meaning. And then the 10, I'll push it inside the brackets here. And then I'll say over a 2. Okay, over a 2 right here. Hopefully you can see. Such that this and this are just this whole thing and this is just the same. So this constant will come in front because 2 into 2 is a 5. So you just write a 5 and the e for this power t plus, oh sorry, sine 2t. So this is our answer. Hopefully you are following. Thank you so much. This question was requested. I was requested to do this, so I've decided to do it for somebody, for one of my subscribers. Thank you so much.